Hi, Brianna. We are on the second half of 3-1. We did the first half of it on Friday. We did quite a bit, I feel like. But now we are on page 139, the top of 139, and we're talking about a scale. So when we're talking coordinate system, like a coordinate plane, right? They do have a set scale that they go by, and this is kind of trips people up sometimes. We a lot of times get into the rut and we assume that it's going by ones every time, but I'm going to caution you to make sure you check that every single time when you're figuring out, like usually one scale, one tick mark is 1 unit, right? But sometimes they will throw you off and they will go by twos or something else, right? Okay? Yeah, so that's what they're going to have us do in example 3. It says use an appropriate scale. This is 5, 80, negative 36, 48, 25, negative 90, this and this and this and this. Okay? Let's talk about step 1. What our x's are going from. So x coordinates are the first coordinate. What is the lowest number I have for x coordinates?
Negative 36.
Negative 36. And what's the highest number?
38.
Positive 38. Okay? All right. The y coordinates are the other ones, right? The second coordinate. What are they going from?
Negative 91 to 20.
Holy moly.
95.
To 95. Negative 91 to 95. Whoa. The x-axis should include values from about this much to about this much. So if I look at these guys.
40.
What?
I say 40.
I would say negative 40 to 40. That sounds really good. What about the other one?
Negative 90 to 100. No, I'd say.
No, because you got negative 91. You got to go outside of that. What?
Negative 100.
I would do probably negative 100 to 100 because those are really nice, easy numbers, right? Okay.
That's no different.
So an appropriate scale on the x-axis is how much?
That's the same number. Negative 100, negative 100 are the same number.
What?
Negative
Oh, I'm just seeing if you're paying attention, Elaine. Positive 100. Bet. An appropriate scale on the x-axis. What should we go by on the x's?
2.
Tens.
I don't know.
Wait, no.
6s.
2s.
2, 4. Not everything. It would have to be either 2s. No, because 5 doesn't go into 2.
20. 4s.
I want to go by
4s.
I want to go by 5s. I'm going to go by 5s on the x-axis. And then what about on the y-axis? Let's go by 10s on the y-axis, right? Okay. So if I go here, right, I'm going to label. And maybe I'm just going to label every other one. So if we're going by 5s on the x-axis and I label every one, like this would be 5, this would be 10, right? Okay. I'm just going to label this one as 10, this one is 20, this one is 30, this one is 40. Is that true, right? Does that work? No, the y-axis is going to, but this one is labeled as 5s. I just didn't mark every single one. Does that make sense? Yeah. Okay. This guy is negative 10, negative 20. Do you see how I'm still going by 5s?
Yeah.
Am I still going by 5s, but I'm just labeling every other one because it's really small, right? This one is going by 10s, so if I label every other one, I'm going to go 20, 40, 60, 80, 100, and I've got negative 10, negative 20, I'm sorry, negative 40. Am I still going by 10s?
Mm-hmm.
Negative 60, negative 80, negative 100. Do you see how that works? Right. Okay. I just am labeling every other one so I don't have so many markings in there and make it like really mumbled, right? Okay.
Can you give us one?
Yep, I sure can. And then we're just going to graph these points-ish, like as close as we can, right? You go ahead and do that real quick. Label your axes, and if you want to start graphing, you sure can. Like start plotting your points.
Why do you always put that stuff in?
Because bottled water tasted terrible. I mean, like the taste of bottled water.
Depends what I'm doing.
Oh, and this is out. Bottled water is filtered water. I have to have dirty water.
Dirty.
Tap water.
Hard water.
I have to drink dirty water.
What is the
Not
difference?
bottled water.
Hard water.
This is filtered water. All of the good dirt has been taken out. I have to have dirty water. It tastes better.
Good dirt.
Honestly, I agree with you. I'm not gonna lie.
I just drink out of my fridge.
Yeah, that's dirty water.
Water.
Hose water?
Honestly,
Nothing better than
the
hose water,
out
right?
there tastes amazing and no crackers.
Okay, we've got, how many points are we plotting? 6? 6 of them? All right, 5, 80. is the first one. 5 comma 80 is a perfect spot right there. He's over 1 and up like, I don't know, 8. Yeah. That's 5 comma 80. Negative 36. Negative 36 is like there. And 48 is up to about there. Right there. Negative 36 comma 48, yeah? Is that the right spot? Ish. Try to get these to the right spot. Okay, 25, negative 91. 25 is here, negative 91 is, right about there. Yeah? That's your next point. I'll circle them so you can see them a little bit bigger. Okay, that's my third one. This is number 1, this is number 2, this is number 3. Can you see my dots? 4 is 38, 95. 38, 95. Right about there. That's number 4. Okay, the fifth one, negative 10, negative 50. That comes out nice. Right there. That's for number 5. Oop. Number 5 is that one. Negative 10, negative 50. And 1 comma 22. 1 comma 22 is about right there. That's number 6. Okay? Those are all my spots. He doesn't really look like too much of anything.
A man.
It looks like a man. I don't see it.
Person. If you like connect all the dots, like just one straight line. Yeah, it would look like this.
Like I see
It
this
looks like
Yeah.
sloth.
A person.
person. Sure.
The sloth.
Yeah, you're just missing the head.
I don't know. Anyway. Okay, good. There's all my dots. Appropriate axis.
He looks like he's out, and then he's about to go in for like a.
He's a stick person doing jumping jacks.
Yeah.
Yeah. Kinda, yeah. We could go with starfish.
I need a lint roller.
No, I don't. Okay, how about that? Good? Moving on? Check. All right, let's see what they say here. For an appropriate scale, let's talk about our x's. What are our x's going from? On the check at the top. What's our lowest x number? Negative 10 to 16. Negative 10 to 16. Okay, then the y's are going from negative 27 to 32. Yeah, is that true? Okay, so what shall we go by on the x's?
2. 5s.
What should we go from?
Negative 20.
I want to go negative 20 to 20. That sounds good. What about the other one?
Negative 20, negative 20. Negative 30. Oh no, like negative 40.
I want to go negative 40 to 40.
10.
Okay? We want to go a little bit outside of the range.
5.
It's fine. That's fine. That's not an option.
20 to 20.
Okay? So the x's, they say negative 20 to 20. I like that. And doing a scale of 1. Sure.
It's either that or a
Sure.
scale of 10.
I wouldn't do a scale of 10. I would do a scale of 5, maybe. The y-axis, we said negative 40 to 40. But they don't give us that option. So what should we do?
Negative 30 to 40. Got it.
But I don't like the scale of 10. That's way too big.
Negative
Let's go
30 to
negative 30 to 35. Let's do that and do a scale of 5. I like that idea. Yeah. Scale of 10 when you're only going, like, just so you know, scale of 10, negative 30 to 40 would only be 1, 2, 3 units this way and 1, 2, 3, 4 units that way. That's not a very big graph. Does that make sense? Yeah. Okay. So, that's what our scale of 10 would be. Actually, it would be up and down. Sorry. We would only go 1, 2, 3, 4 up and 1, 2, 3 down. That's not a very big graph. So I would go by 5s. Because if we go by 5s, how many would be in this direction? 6 in this direction, and how many this way? 7. Oh! All right. Okay, moving on. Example 4. The table shows snowfall in January for Boston. Okay. We snowed a ton in 2005. Wow. We snowed a ton in 2011. We snowed a ton in 2015, wow. And in 2014, there was a lot. 2009 was a lot, right? Okay. I don't know. It kind of goes in cycles, though. Okay. Choose an appropriate origin. Let the x-axis represent the blank and the y-axis represent blank. Then the origin 0, 0 represents something. Okay. So when we have real life data, here's how this works. Instead of doing an axis that looks like this, we're only going to graph this top portion. So we only have like an axis that looks like this. Does that make sense? Okay. And the reason why is because normally you put your time or your years on this axis. Can you go negative in years?
No.
No. And can you go negative in snowfall?
No.
No. So it's better to do like just the top right corner, right? Okay. So choose an appropriate origin. So what are we going to have like our time, like our lowest time be? What would be a good spot for our lowest time to be?
205.
I would have it be 2000 would probably be a good spot. 2000 would be a good spot. Okay.
Since 208.
They did year, what?
Since 2008.
Interesting. Where?
Wait.
No, they didn't.
No, you're on the man.
No. I would do 2000 as a good spot. You could start at 2005. That's fine. That's fine. What are you going to start at on snowfall? Let the x-axis represent the year 2000. And y, let's represent.
0.
I'm just going to start it at 0. The y-axis represent at 0 inches. Okay? So the year 2000 and 0 inches. Then the origin 0, 0 would represent?
2000 0.
Yep, 2000, comma 0. Or 0, actually it'd be 0, comma 2000.
What?
No, you're wrong. X comes first. I'm wrong. You're right.
You're wrong.
2000, comma 0.
Yeah, you're wrong.
You're right. You're right. Okay. Choose an appropriate scale. The snowfall is between 0 and what's our highest?
43.
43. So what should we go?
45.
We could go 45 and go by 5s, sure. Or we could go 50 and still go by 5s, whatever. Okay. Let's go 45 and go by 5s. The y-axis should include values from, oh, wait a second. That was x. The y value should go from 0 to 45. How do I know that snowfall is the y-axis, by the way? How do I know that snowfall should be the y-axis?
Because it's on the right.
Yeah, x and then y. X is your time, so x is on the left, okay? And your, let's see, your total, so the y-axis should go from values, this shouldn't be right, is from 1 to 43.30. There you go. It's going from 1 to 43.3. The y-axis should go 0 to 40 and should have a scale of 5 inches. Sure. That would work for the y scale.
Wait.
Graph the data points on the coordinate plane. I think that there's not enough. How many like little marks are here?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
12. So I'm going to guess that we're not going to have enough if we start at a number other than 2005. I don't think we can start at 2000.
That's what I said.
I think you're right. So 2005 is where we should start. Okay. 2006, 7, 8, 9, 10. I'm going to go 2010 is here. 11, 12, 13, 14, 15, 2015 is here. There we go. Let's do that. I changed my mind because they don't give me a big enough graph. So we're going to start at 2005 instead. Now, I am still going by ones, but I'm going to label every single dot.
I just did.
I know, I could start at 2003, actually, and have enough space. So that would be fine, but I'm not going to. So 0 goes here, and we're going by 5s, right? 5, 10 inches, 15, 20 inches, 25, 30 inches, 40 inches, and I'm going to go all the way up to 50 inches, okay? That would be a good axes. Let's label our axes. This guy is going to be year at the bottom, and this guy is going to be inches, okay? And we need a chart title. So this is snowfall
Recorded in Boston for the month of January.
in Boston
During January.
in January.
What are
axes are these. These are your axes technically. So we're labeling our axes. The horizontal axis is year. The vertical axis is inches. Yeah?
So there's a difference between axes and
Axes is plural. Axis is one. Axes is multiple. Yes.
Okay.
Yeah. Okay. And then we get a plot. Huh, I don't have the number. Somebody read the numbers to me.
2005, 43.3.
43.3. We'll go right there. Next. 06 is how much?
8.1.
8.1. About's there. Next.
1.
1. Right there. Next.
8.3.
8.3. About there-ish. Next.
23.7.
23.7. About there. Next. 2010.
13.2.
13.2. Okay. Next.
38.3.
38.3. About there-ish. Next.
6.8.
6.8. About there-ish. Next. What? 5 exactly? Woo! Okay. Next.
21.8.
21.8. Yeah.
34.
Which one? 30.
34.
34.3. There you go. 215? Yes, you can. Is that it? Okay, now I can see from this graph, like which ones are the high ones, right? Okay, and in what year? So graph kind of tells a story. I just got done doing this with my stats kids. The graph is supposed to help you kind of tell a story about your data, right?
Yep.
It's easy to pick out the highs and the low points. All right? There is my graph. Got it? All right, moving on. Example 5. Is this the last one? Yeah, almost. Almost. Okay.
No. It's a
Did you know you can
Ship your pants. I know, it's a commercial.
Can we see this?
Okay, not yet. Just wait, we're recording. Let's. Yeah, and now it just makes it sound like you guys just said a naughty word. They're not saying naughty words. They're talking about shipping their pants. Okay. Anyway, sorry, Brianna. Example 5. We'll maybe play it here at the end. Here we go. Okay, example 5. Shh. The average number of posts per day on social media sites each year is given in the table. Whoa. I feel like we're in the presentation that we were in the other day. Look at how fast it takes off. 15 million posts per day. That's still quite a bit in 2008. That was like before you were born, right? That was way before you were born. Then we're up to 625 million in 2017, and it's been like way more than that since then, okay? So do you see what this is doing? What abouts is happening there?
It was 100.
Like, what does this look like? Do you know what that graph is? Shh, listen. Shh, it's a what? What kind of curve is that taking?
Linear?
Nope, it's not linear.
Upwards.
It is.
Positive.
Do you know what this is called when it does like this? Whoop, when it goes up really fast?
Goes up.
What is that called?
Rocket ship.
Nope, it starts with an E.
Escalator.
What?
Efficient.
Nope, nope, nope,
Pulley up.
nope, nope,
Hegelia.
Rocket ship.
nope,
Elevator.
nope,
Elevator.
nope,
Elevator.
nope, nope. EX.
Exponential.
Exponential. It increases exponentially, which means it's like going really fast, right? Okay? That's kind of an exponential graph. All right. Interpret the meaning of the axes. Okay, so let's go down here. Let's fill in the blank. The x-axis represents the what?
Years since 2008.
Years since 2008. Because it is not appropriate to start at the year 0, right? Like if we just looked at this, you'd be like, what the heck does that mean? But years since 2008. So 2008 is year 0. 2009 is year 1, etc., right? Okay? The y-axis represents the
Average post per day in the millions.
average posts posts per day in millions. Okay? Scale. The x-axis has a scale of 1 mark equals what?
1 year.
1 year. The y-axis, 1 mark equals
1 million posts.
50 million posts.
1 million posts, I thought.
No, 50 million. 1 mark is from here to here. 1 mark is 50 million posts. Okay? The origin, 0, 0 represents what year?
0. Just kidding.
0 is 2008. And 0 represents 0 posts per day, right?
15.
There you go. That's it. All right, should we interpret the other one? This is coins, circulating coins. Oh boy, look at this. This is interesting, actually. This is the number, if we go to the next graph, the check on the back page, this is the number of coins that are circulating. What does that mean? What does circulating mean?
Like going through, like buying and selling.
Yeah, like how many people, like coins that people have out and about, right? Okay. On average, it's kind of doing what?
Going down.
It's kind of trending downward. Why?
Credit card.
Because people are using credit cards or debit cards or some sort of plastic to pay and they're not using actual change, right? This is years, and it's years since how much?
2001.
2001. So 0 equals 2001. What does 1 equal? 2002. 2 equals 2003. I probably would have started at year 2000, but whatever. Interpret the meaning of the x and y axis. The x-axis represents the years since 2001 and has a scale of 1 mark equals
1 year.
1 year. The y-axis represents the
Circulating coins produced in billions.
billions of circulating coins. And has a scale of 1 mark is how much?
2 billion.
2 billion. Part B, interpret the meaning of the origin. 0, 0 means the year
2001.
2001 and how many coins? 0 billion. 0 billion.
Actually, 18 billion.
What? No, 0, 0. Where does 0, 0 represent? Oh, yeah. Yep. Okay. Good?
No.
All right. Go back? I'll make it short. Maybe.
My brain is gone.
Can we make it short?
This all went over my head.
I'll make it short.
Do it tomorrow.
No.
I have a practice that I won't be able to
watch this video first and then work on it.
6, 8, 10, 12.
You can give us like 6, 7 questions.
Let's do.
Tomorrow.
Oh my goodness.
We should do Caden's idea, the first page by
Talent.
force.
Let's just do 2 through 12 evens. 2 through 12 evens. That's fairly short. 143, 2 through 12 evens. Correct.
I think I can deal with this.
I think you can. I think you can.
So there's like 6, 7 questions, right?
Shut up. It's not funny.
No, actually.
All right, goodbye, Brianna.
Get better at math.
Whoa.
You chose a commercial
7
about
can be a
shaking our
bonus.
hands.
You